Okay. I think, let's see, what did I do? So I'm just doing the BRMS, excuse me, the BRMS package, which I kind of have mixed feelings about that because I don't know, I guess it's good to compare the Ulam versus QApp or whatever, but whatever, that's what I'm doing. This one's pretty easy. I was just doing this myself because I wanted to get up to speed with that. Okay, I think this was one that I signed up for. Question E4. Why do Poisson regressions sometimes require the use of an offset? Give an example. This would be necessary when the rates between two outcomes are different. Data that measures the number of purchases customers make on a weekly basis versus a monthly basis. I'm not sure I was reading through that part. And I was like, okay, I kind of get what's going on here, but did you have any other insight about that?
Well, I guess just on, I mean, I guess two things. One is that I think that we wouldn't say like rates between two outcomes are different. Because rate is the rate. Rate is
the unit time. I would say probably the time measurement of the rate. Right.
So I think that I know that so an offset would be, for example, say that you want to know like purchasing frequency among your customers. And even if you have like you sample daily, like you have daily time windows, if your customers didn't all become customers at the same time, so they have like different windows, you would use, under my understanding of an offset, you would use an offset to say like, all right, this customer was there for 100 days, this customer was there for 50 days. So they have like different windows, even if it's the sampling frequency is the same daily. The total time under observation is different. So that's,
let me look at the book real quick. I'm going to see what it says about that. Purpose. Yeah, the exposure. So you were saying the exposure is different. This is any predictor.
yeah, so I'm looking now at page
357.
57. So you can actually see it go down on 358 in the code. There's a part where it's a blue block saying like, compute the offset. So there it's got, he's like doing log of days, and you see how that enters the, when he's writing model 11.12, you see how it enters basically the rate parameter as like an additive bit.
Yeah. No, I think I get the now I did have the code 11.52 monastery repeat 0 to 30. I'm trying to think why that would be starting at 0. Is that
yeah, I don't know.
I should probably, I feel like the best way to probably read this book is to go through, and maybe you do this, and execute the code in the console, to understand what's going on exactly, and kind of seeing it. So maybe I need to think about that some more.
Yeah. Although, so this one, the code I don't know if you saw this in the Slack, but I think a breaking change was made in Stan such that
I saw you
McElreath
said it is
package.
not working for you anymore. Is it, did you
Yeah.
reinstall?
I
or no,
haven't
you were using the rethinking package, right? To estimate.
exactly.
Okay. Well, then I'm glad I'm tried BRMS then, I guess.
Yeah, I think what I'll have to do is probably reinstall. I'm gonna reinstall rethinking because maybe he's updated it. So because it's not on CRAN. Anyway, the point is that I think the time has come for me to switch just to Stan because that's like under the hood what everyone's using anyway.
That's
So it's
fair.
just like it's time.
Well, good for you. I personally, I don't have the bandwidth to learn learn Stan. But yeah, that's probably a good idea instead of relying on the interface between R and Stan.
I did learn though, and this is nice for you, is that I mean, if you ever wanted to learn, or if you ever wanted to pretend like you know Stan,
Mhm.
there's a BRMS function that I think is called make underscore Stan code, where it'll just
Yeah, I
give you
think.
the Stan code for BRMS
Mhm.
model.
Yeah, I think, and I think he has that in rethinking too, right? Or is
Yeah,
it's not quite maybe the same name, but a similar function.
exactly. It's a similar, yes, same idea, same outcome. But anyway, we don't need to belabor this part.
Yeah, so let's see. I think I did medium two. This one I spent a lot of probably too much time on. If a coefficient in Poisson regression has a value of 1.7, what does this imply about the change in the outcome? So I just got really literal here, which may belie a lack of deeper understanding, but an increase of 1 unit of the predictive variable of interest associated with 1.7 unit increase in the log of lambda sub I, which is the expected value of the outcome. Well, I should say the log of the expected value, I guess. Or, 1 second. How would you phrase that? I don't know if you did this one at all or not.
Uh, well, let's see. So, right. So 1 unit change in the predictor, the relevant predictor would have e to the 1.7. Is that what you wrote
I
in the
said
log?
1.7 years in the 1.7 unit increase in the log, but I guess if we were transforming it to not log, that would make sense. Yeah.
So it has, yeah. So if you do e to the, so exp 1.7 and r, you basically at 5.5. So for every 1 unit increase, you get like a 5.5 times, it's multiplied by a factor
Mhm.
on the original scale. So that's that exponential increase.
Yeah. Okay.
But I think that's right. Do you
Yeah.
remember what you said you thought you overthought this one?
Well, I just was taking it very literally, looking at like from an econometrics perspective. Well, we look at that beta, right? That, and it's the log of that lambda, that rate. Um, and it's like, well, 1 unit increase associated with 1.7 unit increase in the log of lambda. And then I guess, like you said, exponentiation, if you wanted to get to the count variable, like the outcome of interest.
Yeah, that actually reminds me. When I had a friend who took a qualification exam for his PhD, and he hated he didn't really like the quantitative stuff. So he just, whenever he was asked, he knew like kind of what he was supposed to do when he was asked questions about this happens on some scale, what's the change, and blah blah blah. And he would just report like the most stiff sounding, bizarre, you know, like not trying to back transform the variables. He'd be like a 1 unit increase in squared blah 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 log blah blah blah, and the dependent variable without. So he just, yeah, he did it
Well,
very
it's
mechanically.
technically correct, right? So,
Technically correct. Yeah, and he passed. So
well, good for him.
yeah. All right, now I want to learn about
Oh
salamanders.
gosh, this question. I spent probably way too much time on this question, and I did not come up with anything satisfactory. It's probably a me thing. To be fair, I did not watch the video. Just so maybe that's he alludes to that in the question, but so there's some salamander data. These are counts of salamanders from 47 different 49 meter square plots in Northern California. So this is the count in each plot. percent cover and forest age of percent of ground cover, which I think I know what that means, and the age of trees in the plot respectively. So we're going to model salamander as a Poisson variable. So the first part A is model the relationship between density and percent cover using a log link. Use weakly informative priors of your choosing. I'm not going to do this. Plot the expected counts and their 89% interval against percent cover. So what ways does the model do a good job, bad job? This part is pretty simple. So what I'm doing here is I'm just standardizing. I added some log standardization. There was a 0 in the data, so I added 0.0001. Figured probably wouldn't mess it up, although perhaps he would say, McElreath would say differently. So that's basically, you have all these different sites. You can kind of see some places have a lot of cover, other places 0. Yeah, so this is kind of weird. There's like no sound, I guess. I'm not sure what this is. A desert, maybe? I don't know.
Hmm.
And then we have a lot where we have some various levels of percent cover and no salamanders. So what I'm doing here, I just kind of wanted to get a visual of it, just plotting percent standard log and salamanders. So I was like, okay, that doesn't really look like what I'm going to want, because we have this we have little variation right in the x's and like a ton of different stuff. This is percent cover non-standardized versus salamander. It's a little bit better, kind of two groups here. And then this is a standardized variable, similar pattern. So I think we're supposed to do standardized variable of some sort. So I chose this one, just not log, but standardized. So this is just me kind of playing around based on like the log normal distribution. But I followed the format that is in the BRMS guide, which I really appreciate. I changed, this is basically where to put the text. So I changed some of this. This is a vector of means and a vector of standard deviations. I should change, it doesn't need to be log. Well, I guess it does, because it is technically log normal. So basically I'm trying out one, this is for the intercept in 0.5 and then 0 and 0.3. Doing some nesting here, then expanding this out. So this is a lot of, I changed a few things here. What you see essentially is, so if we have alpha, what?
Can you minimize your console so that the
Oh, sure, yeah.
graph?
I always forget to do that. Okay. There we go. Okay. So this is normal 0, 0.3, and this is alpha normal 1, 0.5. Just kind of playing around with that based on some of the formulas for the, I guess this would be the mean. So exponentiation, he gives us, it's the mean of this standard deviation squared divided by 2. I have 3.08 for this value and then 1.04 for the second one. This seemed more reasonable to me because we have a lot of plots with no salamanders. So given the results of the above, let's see, go back to that. We'll go with 0, 0.3. Probably doesn't matter anyways. We have enough data. And the prior isn't horrible. So this is some code that I borrowed from the BRMS guide, changing it up. So I'm assuming we're going with the 0, 0.3. And I'm trying out a few different, I could have assumed a positive relationship between percent cover and count of salamanders. Decided not to do that. So I did the mean of 0 and the various standard deviations. And then this is just some data analysis that makes it easier to plot. This is basically the 2 standard deviations for the standardized variable, exponentiating everything. And standardized percent cover, salamander count. So what was kind of interesting here is this is like the really tight one. Okay, this is the very wide one, 0, 5, right? So this is kind of crazy. Looks like some pretty intense relationships. This one is a little bit more realistic. We have some that are down, some that are up. This one's kind of crazy, but most of them are fairly reasonable. This one is almost maybe a little too tight. We don't get anything that's above like 3 or something. So I thought, well, this is a weakly informative prior that isn't super crazy or super restrictive. Yeah, I could have done a little bit more tweaking of it, but it's a practice problem, right? So gotta budget my time accordingly. So then I basically am saying that. Okay, so the BRM model here is Salaman, and then at the standardized percent, and I'm doing these priors right here. And then let's see. Yeah. So this is the output. Everything converged. We have a strong positive relationship, well, relatively strong positive relationship. And between that, however, I decided to plot, as I said, and I'm not too happy with this because, right, here's the line, here's our data. Down here does a pretty good job, but there's like a lot of at the higher levels of percent cover, there's like a lot of variation here. So something is probably missing, essentially.
Right, but the only, wait, so you're using 2 explanatory variables right now.
Yeah, it's only one. The first part is just percent standardized, and then we have the intercept.
Right. I mean, so that's all that you, I mean, you can only predict one
Exact.
mean for each one. So yeah, one mean for each percent covered.
Yes. Yeah, exactly. But what I'm saying is there's a whole lot of like variation around here. This
Yeah,
model
yeah,
does
yeah.
not seem to be capturing whatever's going on up here in the upper ranges, I guess.
Uh-huh.
Um,
Exactly. Yeah.
here it does a pretty good job, it seems like. Well, reasonable anyways. So then this is where I made a foray into what I would consider not useful stuff. And if I was giving more time to this, I kind of ran out of time. I was working on this today. I would probably brainstorm some other things, but I didn't. So anyways, I decided to add just the logs, this sort of log standardization here just to see what's going on. Then I was like, okay, I'm going to plot the standardized variable versus the salamander count. Okay, maybe like a weak-ish relationship. It's kind of iffy. And then we have, I also wanted to see, I looked at the log for the forest standard and wasn't happy with what it was showing. I guess I could plot that. You want to see that, but yeah, so we have here, so this extreme outlier, right? Because of that 0. And then we have we have not very much variation in the X's and a lot of variation in the Y's. That's kind from a econometric perspective, that this is could be almost thought as practically a vertical line, which is like, okay, what's that really saying? Not much useful to me. So yeah. And then I was curious to see any relationship between these 2 variables. So this is the standardized percent cover and the standardized forest stage. So what's kind of interesting to me is that I see almost like 2 groups here. We have this like low forest age down here. And then we have basically no relationship, I guess, but I was like, well, maybe there's a somewhat slight relationship with the higher, forest ages over here. Probably a little bit of wishful thinking on my part, to be honest.
Yeah, I'm trying to think what this means. I mean, so there's the case that I think if there's like the quadrant that's 0, it's negative for both. And
Yeah.
like that's like you were saying, there's two separate groups. So it looks like there is a pretty
Hmm.
strong linear relationship between uh forest age and
Yeah.
percent cover for when it's young,
Yeah, exactly.
which makes sense.
So, and if thinking about that, I almost would have also, I ended up doing a continuous interaction, right? Because these are both continuous variables. I harken back to chapter 8, I think, where he talks about how to do that. The tulip example was given.
Mhm.
But I think it almost might have been better to have like created a almost a new, like, just doing breaks, a continuous, or I'm not sorry, a discrete variable like high, low, or something like that, right? Below 0, greater than 0. But I did not get around to doing that, but it's an interesting thought. So yeah, so I'm gonna start out by just doing a standard Poisson regression with another, the forest standardization, just using the same prior. I figured it's weakly informative. Um, so cell form. This one, I don't think I printed that. Okay, so what happens here is we still have that strong effect of percent cover. Basically, I mean, I know that we need to look at the entire, but this is a pretty broad range here. Our estimated error is very high relative to the estimate. And some of that might be because of those two different effects of age relative to the percent cover. So all in all, I was kind of not super happy with that. I added this criterion, the PSIS, I think it is. And then this is basically generating the fits. I didn't do this right in terms of the plotting. Plotting is not my strong point, or ggplot, I should say. But there's some weird, kind of weird stuff going on. So if I have more time, I would do that whole holding this constant, choosing the -1, 0, 1. I think that's in chapter 8 where he talks about it. But there's just some weird, um, yeah, weird stuff going on here that made me kind of be like, eh. Yeah, that looks pretty weird. Yeah, gotta look. So I'm going to do a continuous interaction term. So going back to chapter 8, looking at the syntax for this, what I'm doing here is I'm adding the interaction. You can just use those same weakly informative priors. Potentially could do something better, but did not. And then, so I did, I added the leave one out criterion. So I compared all of these, and interestingly, discouragingly, I said the best model is the one that just uses the percent cover. Perhaps a different functional form is better. We could consider just using a model. Probably wouldn't do this because there really didn't seem to be. Let me go back up again.
Wait, what is the Lu criterion? Is that R? It
So
gives you
this
R
is,
squared.
no, it's like the piece, those information criterion. I think it's like leave one out. That's like the pieces
Right.
from the book. That's the criterion. I could use wake if I wanted to, or whatever, however we pronounce it, but I just chose that one. And then this is basically saying this one has the highest, if I call this right here,
Right. Right.
this one is the best. And then these ones, the last one is the worst with the interaction term. So my idea really did not pan out. But I think if I was spending more time on this, I would probably look at creating two discrete camps, basically like high and low on that standardized variable for forest age. And that might be interesting to see if that yielded any results. I could see that being informative for definitely the younger forest age, right? The higher the percent cover, but beyond, for anything above the mean, it really seems like there's not really a strong relationship, I guess. This looks pretty much horizontal to me.
Yeah, but I'm just, what is the LP? It was, I think, the last code that you printed out,
Yeah.
the LPD.
Let's see. We'll compare. Let me.
I think it came out of model.
Oh yeah, the model weight. Yeah. So this,
Yeah.
you want this one? Want me to run this
Oh,
one?
oh yeah, no, I saw it. It was in the output that just disappeared. ELPD diff.
Yeah. Let me look it up real quick. It's something about hello compare. It's apparently no longer multiplied by -2. Um, Making pairwise correlations between each model. The model with largest ELPD. Okay. Uh, let's click onto this.
It's just expected log pointwise predictive density.
Mm-hmm.
That's what it stands for. Oh, okay. Wow.
Yeah, honestly, I have not done a lot of reading about this. I was just trying to rush through this problem to be honest, frankly, to finish it. But yeah, it's the information criterion. I sort of feel like the rethinking package might be a little bit more intuitive in terms of the output, but if you're using the BRMS framework, which or this leave one out, which is kind of a companion package, it seems like this is what they recommend. So I guess I could have used Wike here instead.
Mm-hmm.
So yeah, that was my foray into salamanders and did not end up well. Maybe I should have called a salamander expert and be like, okay, tell me exactly, do we think about these in magnitude or what? So
Yeah, that's interesting. Um,
I think that's putting
it's
it generously. It was a weird problem. You know, I feel like sometimes with these problems, like I'm sure I'm doing something wrong. There must be something that you're supposed to be like, oh man, when I added that variable, look at how much better that model did. I'm trying to think about throwing different kinds of models at it, which I know isn't the right mindset. But of course, I can't just call it Dr. McElreath and be like, hey, no, I'm doing something wrong here. So
yeah, yeah, I often have that. I actually, in his all of his open-ended questions, I usually feel like I don't
yeah.
get an insight, so I must have done something wrong. Like, even if everything
Well,
goes
I feel
okay,
the same way because sometimes I'm like, this is okay, but it's not very good. Yeah. So I don't know if that's any comfort to you or not. That is, you're not alone in that feeling.
yeah. Um, but what I when I was saying that was interesting, what I meant was that it was, I did mean that it was interesting. I just meant specifically that it's that the interaction in the model with the forest age predictor just, they seem to be quite a bit worse as far as these
Mm-hmm.
criteria, which, so
My
that's what surprises me.
my I wonder if possibly this like overwhelm, you know what I mean? Because this clearly is like there's not much. Also, keep in mind too, right? That if we think about, so we do have this, but then we have also all of these up here. So if you had like on forest age right here, you could have like anything, really any of these values are theoretical. I mean, I guess going up here is just like, well, it's, I don't know. So, I mean, maybe it's not super surprising to me when I think about it, but uh, I don't know. I would need to go back to the drawing board, so to speak, and kind of think through how to show that. So, oh well.
Huh. Yeah.
Well, well, do you want to share? You said you had some non-coding problems.
Yeah. Um, so let's see if I can have them appear in a not ugly way.
Well, you've seen my art.rmd files. I don't care if it looks ugly.
Um, okay, yeah, nice. All right. So, all right, so
Oh, what is that for? That's pretty cool with the background. Did you have a different formatting or something?
um so this is something I learned from Mikael one time. And it's nice if you don't have time to like render, or if you don't you want to knit in our markdown. So this is in our markdown. And
Yeah.
there's this
Yeah.
button over here where my cursor currently is that'll change the mode from I don't know how to express exactly what it does, but it kind of renders some things. And so, for example, if there's, and it's not perfect, it's a bit glitchy, like a lot of our studio things. Like here's some latex that should have rendered that just kind of didn't.
Hmm.
I can't really explain why it didn't render right there. It's pretty finicky. Also, it does weird things. Like once I go back now to regular R Markdown, it's gonna have inserted like spaces, or not spaces. It's gonna have inserted line breaks here,
Okay.
which is gonna be kind of annoying to go back and delete those. But anyway, so it's definitely not perfect. Um, but that's how I created that. And as far as the color, that's just through, let's see, I
Oh, the
believe.
settings or something.
Yeah, it's in preferences, and then okay, it's that way. I believe it's code. No, appearance. There it is, of course. And so it's my
Oh,
current.
wow.
So it's
Cool.
set to solarized light. So that's what's generating
Very
that.
good. Cool.
All right. So anyway, now that the important stuff's out of the way, one of the ones these are all gonna be, this is gonna be like 2 minutes. We're gonna talk about this. So last week, and oh, there was this. Oh, I was okay. So for example, last week, there should be a line right there. I guess I did not do this one. Mikael did this one. Why is the logit link appropriate? So anyway, the companion for this week is why is the log link appropriate for a Poisson generalized linear model? And basically, we have our linear equation of something, just being like the intercept plus, and then the sum of all the coefficients times the variables, the variable values. And so that can go from negative infinity to positive infinity. So what we need is something that will, in this case, make it positive. We'll constrain it to be positive.
Mhm.
Anyway, so that's what the log function will do. And so because what we're doing is we're modeling the rate parameter, and rates can't be negative. And so yeah, so we use the log link for that. In fact, I was actually starting here. The only other function I know that is 0 when well, there's what is strictly positive or non-negative is something they use in deep learning called a ReLU function, which I don't think would work in this case. But anyway, it's the only other function. Well, I guess you could an exponential, but that would be a bit weird. In any case, then I have something that he remarks on in the book is that it also changes the assumed relationship between predictors and number of events. So now there's an exponential relationship. So that's what we saw earlier when we were talking about the meaning of a 1.7 predictor.
Yeah.
Uh-huh. So there's that. So basically constraints to be positive, done. This one was a weird one. This is another one where I kind of was like, I don't know what you wanted, Rich. That's, um, just if I research correctly. So the question is, what would it imply to use a logit link for the mean of a Poisson generalized linear model? Can you think of a real research problem for which this would make sense? And so the logit is going to constrain something that goes from negative infinity to positive infinity to go between 0 and 1. And so the rate of a Poisson can go from 0 to positive infinity. So I was like, man, I just, so if there's something
Mhm.
where the maximum rate could be 1, is the only thing I didn't write that for some reason, but if you had a theoretical reason to believe that the maximum rate was 1, like maybe you're modeling some process where, and then I don't think you'd use a Poisson distribution, but like
Yeah, I think what
where,
binomial, right? I mean, that's what I was thinking about logit link, but whatever.
uh-huh,
Logistic
yeah,
regression, essential logistic regression, right? I mean, but yeah, I don't know. I probably need to go back and reread the book on that one. I don't,
yeah, I mean, so it wouldn't necessarily be logistic regression because you would
yeah,
still be using the Poisson to model the outcome,
yeah.
but it's just a very bizarre. Anyway, the answer it was no. I could not think of it. But again, this was one of the ones where I was like, maybe he's thinking of one, and I don't know what it is. So that was a tricky one. Um, let's see. And the last one I looked at was there were 3 in a row, and then so there was 11 medium 6. And I didn't finish out writing this one, but basically the idea is the interesting question to me. Well, okay, I'll just read the question first. So state the constraints for which the binomial and Poisson distributions have maximum entropy. Are the constraints different at all for the binomial and Poisson? That was a pretty interesting why or why not. For some reason, I decided to answer the second one first, and then the LaTeX didn't render. So what's interesting is that the constraints are the same. And this was something that was interesting when I first learned it. Well, I didn't learn about entropy. I didn't start learning it. I did not start learning about entropy until I was reading this book. But so the Poisson is just a limiting case of the binomial, where in the number of trials goes to infinity, and p, the probability of success in any given trial, goes to 0. So they're actually like the same distribution in some sort of deep, profound
Mhm.
way that I can only dimly understand. Um, so anyway, so the same constraints, and then so the constraints for the binomial are just that there's a fixed number of trials, and that the probability of success is the same and independence between the trials, and that's it. So I don't know, but this is just kind of a reading comprehension question from the book. So these aren't like deep thoughts I had or anything. Um, but yeah, then after that there was some co-op stuff from last week.
Oh yeah, yeah. That's the chimpanzee model. Was that the I can't remember if that was the uh that was probably in their binomial, but or no, was that in
Yeah, there was an experiment where
oh
we
pulling
were
the
like
lever or something. Yeah. That's
exactly.
I feel like whenever I said this before, when I read this chapter, and it's not like I've never been exposed to this stuff, although it's been years. I almost feel like I need to like go back reread it again because he'll make a statement and you're like, what? You think you understand, and he'll just like throw something else in there and kind of like leave it hanging and maybe not take it all the way. Maybe that's why I need to watch the videos, I guess. But that's just been my experience of the book a little bit. I mean, I like the book. It's a really interesting way to look at stuff, but it's maybe a little bit different than some other textbooks that I've used over the years.
Yeah, no, I think it's definitely very good. I don't just yes, I mean that definitely happens with me. I feel like it's the slowest textbook reading experience I can recall having. like where
It
I
seems
just
like
need to
he's
go
telling a
really
story.
slow.
Yeah, it's like he's telling a story and then and it'll be good, but then he'll like assume that the reader knows something and kind of hop a couple steps ahead and then maybe circle back sometimes. It's very conversational, which I could see some benefits of that and also some like, wait, where did we just go? That kind of a thing. But that's my opinion about it. But yeah, I don't know. I'm not sure exactly who the target audience is. If it's like people who I'm assuming you wouldn't know, you have to know at least probably have taken some econometrics or statistics to be able to reasonably get something out of this course. But is it people who are in scientific or social sciences disciplines who want to know how to do Bayesian analysis reasonably well without getting into a ton of proofs for their research? Or I don't, maybe it's, early statistics students. I'm not exactly sure.
Yeah, I'm also not sure. There's I think a famous introduction by Nietzsche to one of his books where he said like this book is for everyone and for no one.
Oh gosh, we're gonna go nihilistic.
I think that's right, and maybe I kind of feel like McElreath's book is simultaneously for everyone and for no one.
Yeah, no, I think if I was a student and I had the time and capacity or whatever to devote like the kind of effort I could devote to it, perhaps I'd probably get more. And I was going to his class, be able to ask the questions that pop into my mind. I would probably get more out of it. I think I have gotten some stuff out of it. I learned how to use BRMS, probably wrongly, but I can certainly create models, even if they're crappy models. But so I guess that's a plus. But and I might have some use for some Bayesian analysis, especially logistic regression. But we'll see with my company. I was like, oh well, because they're saying, oh, you don't want to be overconfident. I was like, well, Bayesian, you get back the whole really look at the whole distribution. Oh, I don't know if we need that, So it's like, whatever. You're not in corporate America, so you don't haven't experienced that little. I'm trying to think. What's the most diplomatic way to say this? Mindset.
Yeah, no, I haven't.
Yeah, I don't recommend it. I mean, some things it's good, are better than academia, but I think there's a lot more exploration of things in academia. So, oh well.
Well, one would hope. I think that's kind of, well, yeah, one would hope.
Yeah. It's I'm trying, my current thing is trying to convince this VP at my company and that other pharmaceutical companies are really trying to get into data science, data analytics, and we're still doing a lot of stuff in Excel. We should probably, maybe think about not. It's, oh well, we just need to solve the problem. It's like, okay, but this isn't 2002 anymore. So I don't know. We'll see.
Oh, you can't just lead data science your way and like foot down. Foot
Well,
down.
I,
This
I
is
would if I could. I mean, I can be not super pushy. Well, I can push for what I want, but it's there's a little bit of the dynamic. I don't know. It's a old school kind of mentality, and we'll see. Apparently, though, the new guy, he has experience with SAS, so I'm like, well, SAS R, so that's probably a plus. So we'll see. But yep.
well. All right.
You have
So
the golden, do you have the Golden Girls shirt on? I thought I just saw your shirt. I just commented on that. Yeah. Oh, that's cool. Yeah.
stay
Good
golden.
old Betty White. Good old Betty White.
Yeah, this was a good thrift store purchase.
Yep.
All right. Well, on that note, which we're not going to beat. So next week, next chapter.
Yep.
Whoever's here is here.
I think I should be here. Hopefully, Kent and Mikhail will join us. So
Yeah,
yeah,
I think
we'll
it's
see.
kind of a futile hope, but I hope so. I hope with Kent anyway.
I know, but I feel like, man, dude, you're almost retired. Like, you could phone it in for the last few weeks. Not that I would endorse that, but I'm sure he's busy. But yeah, it's kind of a bummer how this group dwindled so quick. I keep thinking about that, like how many people started, but oh well.
Yeah,
So
and they were so enthusiastic at the beginning too. I remember that. It was
yeah.
such a 20-person meeting and everyone was like, woo,
Oh,
base.
yeah. And it was like 2 weeks and it dropped off, is my memory. Like, maybe there were a few people, but then by like 4 weeks, it was like hardly anybody. So, oh well. Such is life.
Yeah. Well, all right. So I just looked next week, chapter 12.
So like 45 pages or something.
It's it's not 45 pages. It is exactly 30 pages.
Okay, that's not
Or
horrible.
maybe 29 if, well, no, it's 30, yeah. Wow, yeah, full page.
This
Wow,
is
there's
like,
exercise.
yeah, this is like, I feel like right now we're in like mile 17 of a marathon. I've never run a marathon, full disclosure, where it's like you're not that close to the end of the book, but you're kind of like getting there. But you're like, man, the hardest stuff is coming up. So, uh, okay, well, I guess I better get reading then. 30 pages plus some exercises.
30 pages. What I am worried about is that switching away from his Ulam, and so the next chapter is on mixture models, and I'm just like, man,
Mhm.
that is not going to be fun to try to specify in any
Yeah.
Bayesian framework where I have to say like this prior on this. So I wish us both luck specifying these
Yay.
models.
Well, we'll see how it goes.
All right, well, I will see you then.
Okay, see you. Bye bye.